Algebra 2 Honors 9.4, Day 1, Part 2. So there are only a couple of problems that I'm going to have you do with this. I want you to graph y equals -2 sine theta and y equals 0.5 cosine theta between 0 and 2 pi. I have a template for that for you to do your graphs on and fill out the charts on those. And so here are a couple of examples for those, and we're going to start by reviewing the 9.4 Day 1 Part 1 concept with the unit circle. And you will note that in this graph down here, I have filled out all of the ordered pairs. So at 30 degrees, you go long and then up short. So it's √3/2 up 1/2, and et cetera, with all these ordered pairs. And then I have approximations of values. It's good to know that √3/2 is approximately 0.866. √2/2 is approximately 0.707. And of course, 1/2 is 0.5. And so we're using those decimal approximations, and we're going to use this to help us to graph these functions of sine and cosine. And so just to kind of bring it together in terms of evaluating for cosine of 4 pi thirds, you want to go and find where 4 pi third ends, the terminal side, and 4 pi thirds ends right here and hits that terminal. The terminal side hits the unit circle at this ordered pair to the left 1/2 and down √3/2. And so cosine of 4 pi thirds is going to be your x coordinate there. It is x over r. The x value is -1/2, but because r is always 1, it ends up just being that x coordinate of -1/2. And then for the next one, tangent of 7 pi 6, we want to go where we hit 7 pi 6, which is 210 degrees. And so we're looking at having our terminal side end here, and it hits that unit circle at the ordered pair, -√3/2, -1/2. And tangent is y over x. So it's that -1/2 over -√3/2. And if you multiply by the reciprocal, those 2's are going to cancel, and you get negative divided by negative is positive. So you get 1/√3, and rationalize is √3/3. Remember, all students take calculus. The tangent and cotangent are positive in quadrant 3. The other 4 are negative. For cosecant of a -60 degrees, you need to rotate clockwise, and a -60 degrees is going to put you at the same spot as 300 degrees. That -60 degrees puts you at what would be 300 degrees if we went counterclockwise. And the ordered pair there is 1/2 and down a -√3/2. Cosecant is the reciprocal of sine, and so it is r over y. And so for that ordered, the r value is 1 and the y value is -√3/2. So that is a -2/√3, and then rationalize gives you -2√3/3. And so in the previous notes, I had done one quadrant at a time, and we looked at all these ordered pairs. Now we want where you can just write out all those ordered pairs in pretty quick amount of time, and then use it to evaluate the trig functions. So tangent of a -270 degrees. So just getting some of those cleared up. Tangent of a -270 degrees, you are rotating clockwise 3 sets of 90, or 3/4 of the way around, and it puts you at the same spot as 90 degrees or pi halves. And so the ordered pair where the terminal side hits the unit circle is 0, 1. And so tangent of -270 is going to be your y over your x. It is going to be 1/0, and that is undefined. So now we're going to use the unit circle and these decimal approximations to graph y is equal to sine of x. So we're looking at order xy ordered pairs that satisfy this, and we're going to let x our angle be in radians in this case. And so we're going to give our angles as we go around the circle, unit circle of pi 6, pi 4s, pi thirds, pi halves, 2 pi thirds, 3 pi 4s, 5 pi 6. Those are all these radian angle values that we're using. And so as we go around on the unit circle, these ordered pairs are cosine x sine x, if x is your angle. That is going to be these ordered pairs, meaning that right here, root 3 over 2 is the cosine of pi 6, and 1/2 is the sine of pi 6. So if I just look at the y values at each of these points, I am going to get the sine of that angle. So if I start with 0 degrees, at 0 the y coordinate is 0, and so the sine of 0 is 0. At pi 6, the y coordinate is 1/2. So the sine of pi 6 is 1/2. And pi fourths, the sine of pi fourths is going to be the y value at pi fourths, which is root 2 over 2, but we want these to 2 decimal places. So I'm actually going to change the 1/2 to 0.5. We don't need 2 decimals there because it's exactly 1/2. But at pi fourths, root 2 over 2 is 0.71. And then we're going to go to pi thirds, and sine of pi thirds is root 3 over 2, or 0.87. And sine of pi halves is the y coordinate at 90 degrees at pi halves. It's 1. And at 2 pi thirds, we are at root 3 over 2 again, which is that 0.87. And at 3 pi fourths, we're going to be at root 2 over 2, which is 0.707. Then at 5 pi 6, we're going to be at 0.5. And when we get to pi, we're going to be at 0. So using those values, we've got 0.87, 0.71, and 0.5 at 5 pi 6. And at pi, we are at 0 again. And then continue to go around the unit circle and use the y coordinates. At 7 pi 6, we'll be at negative 1/2. 5 pi fourths, negative root 2 over 2. 4 pi thirds, that negative root 3 over 2. Or for decimals, we've got these 3 y values. So the sine of 7 pi 6 is your negative 0.5. And sine of 5 pi fourths is negative 0.71. And sine of 4 pi thirds is negative 0.87. And then I filled out the rest of the chart because you're just continuing to go. At 3 pi halves, sine's negative 1. At 5 pi thirds, it's negative root 3 over 2, or with decimals, negative 0.87. At 7 pi fourths, it's going to be negative 0.71. And at an 11 pi 6, it's going to be at negative 0.5. And at a full rotation of 2 pi, the y coordinate is 0. So those are the decimal approximations for one. We're going to be talking about one cycle, one period of sine. And then we're going to graph these. So I approximated a few of these. And so on this graph, I have it divided into 15 degrees. So from 0, you're going 15, 30, 45, 60, 75, and then we hit our 90 degree. And so we're going to be using the 30 degree of pi 6, the 45 of pi fourths, and then the 60 degree, which is your pi thirds, and then you skip over, and then you'll be at pi halves. So after pi halves, the 120 degrees, or 2 pi thirds, is here, 3 pi fourths is here, 5 pi 6 is here. After pi, 7 pi 6, 5 pi fourths, 4 pi thirds. After 3 pi halves, we're going to be at 5 pi thirds, 7 pi fourths, and 11 pi sixths, and then 2 pi. And so just, they're going by increments of 15 degrees or pi twelfths. So we're not going to use every mark on that. So now as we go to graph these, sine of 0 is 0. So we have a point of 0, 0. At pi 6, we're at 1/2. And now you have to realize I'm going by 0.2, 0.4, 0.6, 0.8 on this y-axis. So at pi 6, you're at 1/2. 0.5 is about here. And at pi 4 is at 0.71. You're about halfway in between 0.6 and 0.8. And at pi thirds, you're at 0.87, which is getting close to 0.9. And at pi halves, you're up at 1. Now, the sine graph is what we say concave down. It's a smooth curve that is concave down. And I want you to make sure that you have it look like it is concave down. It isn't looking like it is an absolute value graph. So when you go to graph this, I don't want it looking like this. It needs to instead, from 0 to pi, be what I call concave down. It's scooped down. And then if we continue, this value is that 7 pi 6. Then we have 5 pi fourths. And then 4 pi thirds. We're in that third quadrant. And 7 pi 6 is going to be a negative 0.5. And so here we're at negative 0.2, negative 0.4, negative 0.6, negative 0.8, and negative 1. At 5 pi fourths, we're at negative 0.71. And at 4 pi thirds, we're at a negative 0.87. And then I filled in the others. So just plotting those. And now when we change after pi, instead of being scooped down, it's scooped up. We say it's concave, the graph is concave up. And this pattern continues, so it actually continues here, continues to left, and goes forever. The domain is all reals, and the range is from -1 to 1 for sine. So there's your sine graph. And if we do y equals 1/2 sine theta, then all these y values are going to be multiplied by 1/2. And so I'd plot those. Half of 0 is 0. Half of 0.5 is 0.25. Half of 0.70, remember it was 707? Well, that's going to be close to just 0.35. And the 87 was 0.866. Half of that is 0.433. Half of 1 is 0.5. And then we had that 0.866, which half of that is 0.43. The half of 0.707 is 0.35, and half of 0.5 is 0.25, and half is 0, 0. And if I start graphing those, well, kind of the key point would be 0. At pi halves, you'd be at 1/2, and then back at pi, you're at 0. And all of these are half of what they were. You're at 0.25. You're at 0.35. You are at 0.43. And then you get up to 1/2. And then these values repeat: 0.43, 0.35, 0.25, and then to 0. And so it only goes up half of the amount it did before, so it won't get up to 1, it'll only get up to 1/2. And there's that first part that's concave down, again, trying to make it curved. And then if we go where it's negative, we get the same values kind of repeating in a pattern: negative 0.25, negative 0.35, negative 0.43, negative 0.5, negative 0.43, negative 0.35, negative 0.25, and back to 0. So we are going to be at halfway, we'll be at negative 0.5, and then back to 0. And then all these values are half. We're at 0.25, negative 0.25, negative 0.35, negative 0.43, and then 1/2. And those values are being repeated, but in reverse order. And so then we plot, and there we have a graph of one cycle, what we'll say one period of y equals 1/2 sine theta. And it would continue on both to the left and to the right. So there's your graph of y equals sine x. And some key points on that are at 0, it's at 0. At pi halves, we're at 1. Pi, we're back to 0. 3 pi halves, we're at negative 1. And at 2 pi, we're back to 0. Those really, they're the quadrantal angles. Those are some key values that we're going to be working on as we continue graphing these. All right, so there's sine. What does cosine look like? Well, we're going to start the same kind of thing with cosine with the same graph. And we've got the same unit circle repeated just so that we could have it a little bit closer and not have to go back to the other page. But with cosine, it is the x values on the unit circle that we are plotting. So cosine of 0 degrees is 1. It is this value right here, 1. And then cosine of pi 6 is root 3 over 2, or 0.866. Cosine of pi 4 is root 2 over 2, or 0.707. Cosine of 60 degrees, or pi thirds, is 0.5. You're using the x values. And then cosine of 90 degrees is 0. So if we use those to fill in, you'll see we've got 1, 0.87 to do 2 decimals, 0.71 to 2 decimals, 0.5, and sine of pi halves is 0. And then if we continue with those x values, we're going to have the negative 1/2 or negative 0.5, the negative root 2 over 2 or negative 0.707, negative root 3 over 2, which is negative 0.866, and then the negative 1. So cosine of 2 pi thirds is that negative 0.5. Cosine in quadrant 2 is negative because it deals with x. Remember that all students take calculus. Only sine and cosecant are positive in quadrant 2. So that means cosine is going to be negative in quadrant 2. Again, cosine in quadrant 2, cosine's x over r. X is negative in quadrant 2. And so cosine of that 3 pi fourths is the x coordinate there, negative 0.71. Cosine of 5 pi 6 is a negative 0.87. And cosine of pi is negative 1. Continuing in quadrant 3, I remember it's all students take calculus. Tangent is positive, therefore cotangent is positive in quadrant 3. That means cosine's still negative in quadrant 3. And it makes sense because the x values, cosine of 7 pi 6 is negative 0.86. Cosine of 5 pi fourths, negative 0.707. Cosine of 4 pi thirds, negative 1/2. And cosine of 270 or 3 pi halves is 0. Cosine's negative. It deals with x in quadrant 3, and x is negative in quadrant 3. So cosine of 7 pi 6, negative 0.87. 5 pi fourths, negative 0.71. 4 pi thirds, negative 0.5. And then we're to 0. And then I filled in the rest. You're just going to, in quadrant 4, remember it's all students take calculus. So finally, cosine is positive in quadrant 4, and its reciprocal function secant is positive in quadrant 4. And that's because your x coordinate is positive in quadrant 4. So Cosine of 5 pi thirds is 0.5. Cosine of 7 pi fourths, 7.71. Cosine of 11 pi 6, 0.866. And so those values are already filled in for you. So let's graph this y equals cosine of theta. So it's this y equals cosine of x. So if we use these points and start plotting, I already plotted the first one. You start up at 1. Remember, this is 0.2, 0.4, 0.6, 0.8. You're at negative 0.2, negative 0.4, negative 0.6, and negative 0.8. And we're going by 15 degrees, so we are using the middle 3 ones in between each of these marked values. These are going to be your 60, 45, and 30 degree reference angles. They're going to correspond with the angles as you go around, the pi 6, the pi fourths, the pi thirds, and the pi halves. That's going to be what I've got marked here. And so we have 0, 1, and then this is at your pi 6, we're at 0.87, at pi fourths, we're at 0.71, at pi thirds, we're at 0.5, and then 0 at pi halves. And then at 2 pi thirds, cosine's negative 0.5, and at 3 pi fourths, oops, it is going to be that negative 0.71. And at 5 pi 6, you're going to be at that 0.87. And then I filled in the third quadrant values of negative 0.87, 0.71, and 0.5. And then it's 0 at 3 pi halves, and then we are at 5 pi thirds, and then 7 pi fourths, and 11 pi 6. And at 5 pi thirds, you're at 0.5. At 7 pi fourths, you're at that 0.71. And at 11 pi 6, you're at that 0.87. And at 2 pi, you're up at, oops, not quite, you're up at 1. And then it looks a lot like sine, but it doesn't. Sine started at 0 and went up. Cosine starts at 1 and starts coming down, but it's concave down, curved down in that first quadrant. But then it changes to scooped up and concave up from quadrant 2 all the way to through quadrant 3, and then in quadrant 4 it's scooped down again. And then it's the highest it gets is 1, so it's going to continue both to left and right by decreasing or going down. And there is what we would say one period of cosine. One period of cosine. Domain, all reals, range negative 1 to 1. Well, then if I instead go and graph y equals negative 2 cosine, the negative 2 reflects it in the x-axis, just like our normal transformations, and the 2 is a vertical stretch. And so if I think about this first point of 0, 1, if I reflect it, it's at 0, negative 1, and multiply it by 2, we're at 0, negative 2. But again, what you can do is just take all these y values and multiply by negative 2. That's what we're going to do, because we have the basic footprint of cosine, and we're taking each of those values and multiplying by negative 2. So I've gone ahead, and if I take those decimal approximations, here's what I'm getting, and I just have it for one decimal place for y equals negative 2 cosine theta. And I have filled it in, but I've just taken all the y values for the second row and multiplied by negative 2 and rounded to the nearest tenth. So At pi 6, you're at a negative 1.7. So 0.246. So that's about here. And for pi 4, so at a negative 1.4. So negative 1.2.4. And at pi thirds, you're at a negative 1. And then at pi halves, you're at 0. Again, it got reflected and multiplied by 2. So at 2 pi thirds, you're going to be at 1. At 3 pi fourths, you're at 1.4. And then at 5 pi 6, you're at 1.7. And at pi, you're up at 2. And then at 7 pi 6, you're at that 1.7 again. At 5 pi fourths, you're at 1.4. And at 4 pi thirds, you are at 1. And at 3 pi halves, you're at 0. And then at 5 pi thirds, you're at negative 1. 7 pi fourths, you're at negative 1.4. And then you're at 11 pi 6, you're at 1.7. And at 2 pi, you're at that negative 2. And again, you want it so that it's rounded, scooped up. Then it changes to being scooped down. And then it's rounded and then scooped up. So I only have you graphing 2 of these. And then we'll look at some other ways of graphing when we do the 9.4 day 2 notes. And so I just have a couple of homework problems. I gave you a template. I want all the values in the chart filled out just like we did in these notes.